This video is an introduction to causal graphs. In a causal graph, there are variables and arrows that connect them. The arrows are also called directed edges. Each arrow represents a direct causal relationship. So in this graph, TV watching is a direct cause of diet and of exercise, but not of body mass index. In contrast, in a graph in which the edges are undirected, we cannot make causal claims about the relationship between the variables. For example, without some further guide as to what undirected edges represent, this graph supports no causal claims. A direct cause is also called a parent, and the direct effect of a cause is also called a child. Here, TV is the parent of exercise and diet, and exercise and diet are the children of TV. Two variables that have any sort of edge between them are said to be adjacent. For example, TV and exercise are adjacent, exercise and BMI are adjacent, but TV and BMI are not adjacent. The idea of adjacency applies to undirected graphs as well. So this undirected graph has the same adjacencies as the previous causal graph. Causal graphs take no stand on how one defines direct cause. They represent which direct causes you think hold among the variables that you are modeling. Causal graphs do not presume to include all the variables that are involved in the real causal mechanism. For example, in this causal graph, TV is the only direct cause of exercise. But one's disposition, age, and other factors surely also directly affect the amount of exercise a given individual engages in each week. One need not include all other variables which influence a given variable in a causal graph. So in summary, causal graphs use directed edges to represent the direct causal relations between variables you choose to model, but they take no stand on how to define direct cause. The direct causes of a variable are also called its parents, and the direct effects of a variable are also called its children. Two variables that have an edge in either direction between them are said to be adjacent, and this applies to graphs with undirected edges as well.